What is Jeremiah sharing? He's got his phone held up to the camera, and I can't make out what it is.
Oh, Jeremiah? Oh, oops. Sorry, I just muted him. What are you sharing, sir?
Okay, I was trying to show you guys this. So,
well, you just
it's an interesting little gadget.
It's open discussion. You don't have to hide in the background. Just
just waiting for you guys to finish up your discussion. Not wanting to disrupt or change the subject. We were not on the topic of engineering. But anyways, here we go. This is a impulse cannon that was designed by some unknown fella in the 1965s. And so what apparently it does is, and I'm gonna actually, I'll bring this whole thing over so you can see it. As we can.
Is that the soliton one?
That's a familiar word. Wait, what does this have to do with solitons?
Oh, that's okay. That's different. Soliton's the air. There may be a different word, but the soliton is the air donuts.
Anyway, so I built this.
Oh yeah, that's an example of one.
And it's a pretty simple, straightforward Van de Graaff, except for it is non-triboelectric, meaning it does not use friction between dissimilar surfaces. So,
hey, can you speak up a little? I couldn't catch that. It does not use what?
It does not use triboelectrics. So it's got metal rollers on the top and bottom. And the way that this thing works is it injects charges directly onto the surface of the belt, and then it carries them and mechanically separates them away. And on one side of the belt is a plate that's the roller. It's got nice soft edges and it's a nice smooth surface. So that's on the underside of the belt. And then from above it is an ion sprayer that has a jet, which shoots off the belt, which sticks to the surface of the belt, but mechanically the surface of the roller that is metallic and conductive, it is not really able to give off very many ions because it's got a nice smooth surface. So when the belt separates from it, only the charges that were deposited from the ions from the air stick with it. And
so it's a Van de Graaff, right? Just a Van de Graaff.
Van de Graaff, but it doesn't rely on triboelectrics or the dryness of the air or anything like that. So it pumps out, basically it pumps out stupid charge. And to the extent that it'll jack out a 7-inch spark once a second. And so here's the inside of the top of what that looks like. I guess, unfortunately, a lighting situation here is really horrible, but yeah, so very simple brush roller metal top design. And inside of it, motor driven, very simple flyback transformer design. Anyways, so the idea was simple. You take the output from this Van de Graaff and allow the charge to build up and then make it go through, force it to go through. Let me see, where is my video? A glass tube that the spark would enter this side. It would go through the center here. It would out the center of the glass tube here, and it would have to actually bend 90 degrees before hitting the ground plate that's located behind the exit point. So what would happen is, if it was an electron that was the leader electron from the start, and the electrons all started tunneling this way from the input of this tube, and they accelerated the entire time trying to reach the ground electrode, that would be the positive electrode over here, they would have all of that acceleration momentum, that field that they will build up just like a cyclotron, just like a synchrotron emission, and at which point they would turn 90 degrees, and so all of their forward momentum, their synchrotron radiation, would still be traveling forward, but their direction, their vector momentum was now traveling 90 degrees to reach the ground plane, and as a result, the vector momentum that was built up, the synchrotron radiation has to continue being forward radiated, and it's radiated out as a forward vector momentum, which is the electron acceleration only in that one direction. See, at least that's the idea behind the principle of how this is supposed to work. It's an asymmetric particle accelerator. And you're using the
Where's the electron go? You said the vector momentum was transmitted out, like
the vector momentum goes down the tube, then it turns 90 degrees, and then it hits the ground plate. And because the electron does not strike the ground plate, the momentum that
you went out for a second. The electron it stops at the when it reaches the end over here.
If at the end of this glass tube, I just had a plate like a washer or a ball electrode.
Okay, gotcha. So there's a metal barrier.
Right, metal barrier. The electron would just simply accelerate. It would gain all of its momentum, and the second that it hit that plate, it would immediately disintegrate all back into the plate, and everything be back in balance because the circuit was completed. But something weird happens when you make it turn 90 degrees, because now the energy from the electron, the momentum, is not being delivered in the same direction the electron was traveling. It's being delivered at a 90-degree direction, the direction the electron was accelerated in.
It emits photons when you curve the electron like that.
What's that?
At synchrotron radiation, it emits photons. That's
right,
what keeps it straight.
Yeah, that's what I think this is. I think basically this is just like synchrotron radiation is effectively what it's doing.
So you're making a laser kind of.
Right, exactly, and it supposedly produces a radiative beam that's like a cone taper out of the front.
Yeah, it would be a cone, not laser, because there's nothing keeping it confined.
Right, exactly.
Do you know the energy of the photons, like what type of energy they are?
It'd be related to the how fast the electron was moving when they curved it.
Well,
You need to talk to a plasma physicist more than me. I'm not a plasma physicist.
It accelerates a distance of 6 inches, having built up already under a 450,000 volt field. And in that distance, the mean free path of an electron, supposing zero impacts with any neutral air molecules, what would the actual possible maximum acceleration be for the electric field of that charged particle? That's a damn good question, but we know the figures. It's a 5-inch path, and it's 150 kV.
Jeremiah, are you familiar with the electromagnetic potential?
What do you mean? Yeah, I'm familiar with.
I've been trying to understand it better. Wondering if it could be used as a medium, like I was wondering if you could transfer information without energy by creating waves in the electromagnetic potential. I've been trying to figure out maybe if momentum transfer is possible, if that could be somehow used for propulsion in theory. Usually I just try to figure out if something's possible, and practical always would be the next question. But usually I try to go from something not being able to move at all to, in theory, could you get it to move? But I've been very interested in the electromagnetic potential. And there's a lot of arguments back and forth on how real it is, and I think earlier there was mention to the Aharonov-Bohm experiment, but I'm just wondering if it has any sort of classical reality, if it's more than, because are you familiar with the causing a phase shift? If you send electrons on two sides of a solenoid, there's a magnetic field inside the solenoid, but the vector potential is.
Yeah, I'm familiar with.
Is your background in physics?
What's that?
Do you have a degree in physics or background in physics, or I'm just curious what your background is.
I have a background in physics. I don't have a degree in physics. I'm not classically trained. I've never been to college. I do teach college students on occasion when asked.
But you know stuff, so I just didn't know how. I didn't know who I was talking to. Okay, so you're familiar.
Yeah.
I don't know. Do you have any thoughts? I've been very, very curious about this. In my E&M book, they just kind of mention it. They're like, "Yep, you can." The curl of A gives you B, and it's more of like a mathematical construct. And I've been trying to figure out if there's any physical effects I could exploit for various purposes.
Okay, so straightforwardly, you have the Lorentz transform, which is going to be your direct force on any charge with any magnetic field. So any B cross E is going to be your Lorentz force, and that one's a well understood force, and it causes a particle to curl along what otherwise would be linear trajectory, and the angle of the curl is based on the forward momentum of the particle and the strength of the flux. So So it's an interesting phenomenon because the momentum of the curl is not delivered to the magnetic field that produces the charged particle to curl. And the reason for why this is because the momentum is coming from the frame of reference of the charged particle. It's not actually curling. It's just simply following what is to it a zero electric flux. So it's trying to follow along a zero electric flux line, and it does. It's to the charged particle, to the electron that's making its curved path. It doesn't accelerate. It just changes direction, and it maintains its angular momentum. It just is a different angular vector, and so there isn't a need for the force, interestingly enough. But the funny thing about that is, because it's an instantaneous thing that happens locally at the location of the charged particle, and because it's kind of unidirectional, the charged particle, you can change the momentum vector and re-deliver the momentum from an accelerated particle in a different direction than the one that you accelerated it in. So keep that in mind for the purpose of accelerating a particle and trying to deliver that energy in a way that's useful for a nonlinear propulsion system, meaning a propulsion system that delivers momentum in a direction that is non-equilibrium. So
Wait, how are you changing the momentum of the charged particle?
Through a magnetic field.
Okay, so I guess my question has to do with A. Could I modulate A to change the momentum? No, right? I can't change the momentum. I'm trying to figure out if I could.
Well, you have a fixed number of charged particles that you're moving. So you're already limited to a quantity there. You have a fixed quantity of charged particles, and you have a fixed distance that you can accelerate them within. And you have some kind of fixed potential that you can accelerate them under. Now you have some kind of B flux that you can apply, and that can be a time-varying field, which means that it doesn't.
Can I make a time-varying A? No E, no B. So like you have take the solenoid, right? I put a current through it. Eventually, I'm with the Aharonov bomb. I guess I'm talking about a time-dependent Aharonov bomb, which hasn't actually been done, and there's debate on whether or not you could. But the question is, if you put current through the coil, you have a magnetic field inside. Imagine it's an infinite solenoid. I know you can't have an infinite solenoid experimentally, but long enough and careful experimentation. There's no magnetic field outside of it, right?
Well, I don't fundamentally look at it from that simple engineering standpoint. That's the heavy side adaptation, and it completely removes the reality of what the fields actually look like and where they're going. So if you use that model, you will eliminate for yourself the possibility of creating this type of drive. It's the same reason why that other experiment is funny to me, where you send an electron down two paths of a solenoid that has a current flowing through it, and they shouldn't be affected, but they are. And the reason for that is obvious to anybody that understands the electric fields of the moving charged particles, which have a different momentum and a different electric field than they would at rest. But to anybody who doesn't understand that, it makes absolutely no sense, because technically they should be all at rest because they're in a static potential, meaning that if you try to...
Are you saying that from the electron's point of view, if I'm, in the reference frame with the charged particle whizzing by the coil, I will see magnetic field or electric, I will see electric or magnetic field, and I will feel a force.
Yep.
Okay, but then if I jump to the reference frame of the experimenter, I'm looking at the coil of wire. There's current going through it. There's a magnetic field inside, but there's no electric or magnetic field outside. And I'm like, that the electron is there's a phase shift, and how's that happening? And then they usually say it's a quantum mechanical effect. And when the two electrons,
just calculate the difference in the path length between the two and where they're going to be converged. So. It really makes it just you're thinking about think about it this way. Every single electron that goes through the wire emits a field. Now it's not moving very fast, but it does emit a field, and even though it's kind of just dragging slowly along at a couple centimeters per second, and let's say it's a copper coil, for example, slowly along a couple of millimeters actually per second at a reasonable current. It still has a radiated field that altogether the mass of all of the electrons in the entire coil relativistically are not at zero in terms of their velocity. They're at something slightly greater than zero, and that something slightly greater than zero is the entirety of where the strength from the magnetic field of the electromagnet comes from. It's the fact that they're just moving slightly. And so the electrons that whiz past in their split path, because they feel that slight motion difference, they have a tiny variation in the path length that they take because they feel the slight momentum of the directional force from the individuated charges from the current
That's
flow.
brilliant. Well, you say so. There's a shift in the path length, and that's what causes the phase shift.
Right.
So it's not. It doesn't have to be a quantum effect. This could be a classical effect.
Very classic. Yeah. It doesn't need. There's no need for it to be complicated at all. When I looked at that experiment, to me, I thought to myself, that just really doesn't make. That doesn't need to go outside of Steinmetz. You can find that in Frank's book. It's a very old phenomena that's like classically electromechanical, electrodynamic, and I didn't understand why it needed to be so complicated.
I'm just mind blown. I'm going to bring this to my professors. The number of times where I've brought something to my professors and like, that's so simple. How do we all miss that for like decades? And that's brilliant. All right.
Think about this. Cool. Okay, you'll love this, Jason. You'll love this because nobody wants to talk about this. I swear to God, I don't want to talk about it. Okay, go ahead and make that up.
I can't hear you that well when you're all the way on the other side of the room, though.
Don't worry, I'm just kind of talking. I'll be right on over, grabbing this and a magnet, a couple of things. I'll show you.
Seriously, we need to have a Manhattan Project for like warp drive or space drive. We just got to get the smartest people on the planet and put them in a room.
if you guys are Googling, here's one article. I just saw another one. There's commercial fusion is starting to move forward again.
Okay, so this is you guys will love this. It's too simple, and this idea is really interesting. I want you to think about this as a thought experiment. Here we have a CD-ROM that I've sanded off with the sander on one side, left the other side alone. And inside this, we have a motor and a battery with a little magnet switch. You can't see it because of the lighting situation, but I can put this disc onto this hub, and I can stick this magnet on the side without physically having to touch any of the electrical parts of the motor or its electrical power circuitry, and I've activated it now, and the disc is spinning up, in fact, and it is rotating. And so this will spin up to about 6,000 RPMs, which is sufficient. And so I want you to think about this. If I were to deposit charges on the surface of this disc, like positive charges or negative charges, doesn't matter, and I were to rotate them relative to some stationary set of charges that didn't move at all, that I just somehow kept locked in place. Okay, like they were trapped on the surface of another dielectric that was on the other side. And let's say that I deposited the charges of these on these two discs, one on this rotating disc and one on the other disc, with two jets of ion sprayers from opposite sides of opposite discs. Each ion sprayer, its own independent circuit, its own independent polarity, being fed from, let's say, a dual polarity Wimshurst, for example, where you have no physical connection to ground. And so what would happen is we would, onto this disc, we would spray just one of those two charges, and it would rotate them around, and they would rotate relative to the other disc that have charges sprayed onto it, but it would be stationary. And so over time, if you think about it this way, if you make a charge move, if you rotate a charge,
yeah, it's accelerating, it's radiating.
Magnetic field around here, and you rotate that charge through a B flux, and the energy has nowhere to go. What happens to the potential from the outside frame of reference from a very, very far distance away over time, if we were to try to measure what happens to this thing locally? What would happen to this if I rotated a positive charge on this disk locally, and I just left it sit there and rotating, for a very long time, and it was just a positive charge of the equal amount of a negative charge that wasn't rotating?
I have my guess. Wait, your positive charge is rotating, it's accelerating. All I can think is it's going to radiate, but you're saying it's in a magnetic field.
Right. It needs to pass through a B flux. It's necessary for it to pass through a magnetic field in order for it to have a Lorentz force exerted on it. But the force has no place to go.
Suggesting that it would move? I'm trying to make sure I.
Well,
You're getting rid of negative torque and pulsing the motor and its resonance to get going, essentially, right?
The motor isn't being pulsed. It's a brush motor, so there's no pulsing going on.
You're talking about the plate, and the doesn't now when you're rotating that, doesn't the electron potential smear out? If I remember right.
What happens is the charges are now in motion relative to everything else in the craft. They're also in motion relative to the oppositely charged capacitor plate, which isn't. And so what happens is the plate that doesn't move sees these charges that are now in motion as having an increase in their electrostatic potential. So they appear to have more charge. The voltage appears to go up. Now, technically, the funny thing about this is in a capacitor, you're supposed to only have an equal and opposite number of charges. So you should have an exactly opposite number of electrons that you take from one plate and you deposit onto the other. And you're not supposed to have any situation in which you can have a not balanced quantity of electrons between the two sides, So what happens here is one of these two sides has a balanced quantity of charges, but they're in motion, and the other side has a balanced quantity of charges, but they're not in motion. And so the side with the charges in motion has a field that it produces. That's a field that's caused only by the motion of the charges. And this field is immediately produced the second the charge changes its angle because it's rotating on a disk. It is radiated away from the surface of where the charge exists, and it travels outwards and now hits the stationary charges. And it's picked up as a motional charge with a slightly increased voltage. So this charge wants to respond, and it can't because it's trapped. So it pulls in order to try to, neutralize out and respond to the increased voltage. It tries to displace from wherever it was to move slightly forward. And so there's an unbalanced force where the disk that spins doesn't have any force on it. And the disk that doesn't spin has a tremendous force that it feels pulled towards the disk that spins.
That's Alexei Cherkov's gravifier.
Well, it's similar to Alexei Cherkov's gravifier. That's the basis of the Van Dirac drive. And I think that the gravifier operates by a very similar principle. The idea, though, is interesting that it builds up over time, that it's a not instantaneous effect, and you don't see it when you first turn it on.
I don't think, Jason, you're probably not familiar with Cherkov's gravifier, right?
No, I guess not. What is?
Here, I'll share my screen. That's now Richard Van Diric's thing is something completely different, but.
I see a picture of a field and I'm excited. Just because if I see a picture of a field, I'm thinking something's gonna fly. So it's either gonna be awesome or...
There we go. Sorry about that. Yeah, have you seen that one?
I'm trying to make it out. It looks like some sort of drone-looking thing, but
I don't know. Well, it's what Jeremiah was talking about. So he's got two discs. One is rotating. He's got I think a sewing machine motor. What's interesting about this is pretty much everybody I know thinks that this is fake. I kind of think it's fake too. Just nobody's really figured out how he's faked it. So I think what Jeremiah is suggesting is maybe it's not fake.
The video he did where he's out.
It's a good fake, man. If it's a fake, it's a good fake.
That's Well, I mean, that's the. Yeah,
No,
this
I
is
think
the.
it's real.
I edited this one. Actually, I have a 4K version of this too, but the problem was the one that he posted was incredibly dark, so I had to lighten this one. And when it came
he's
out,
putting his hand on top of it to show that there's no like invisible thread or something, suspending it. But maybe there's like 3 threads from the. I'm trying to see if he walks all the way around it.
he does. He walks around it, and then he does.
But like, how does it work? Like, why doesn't he?
Why
Like,
isn't the Tesla voltage shocking the crap out of him? He's got a Tesla coil, this thing.
But a Tesla coil won't necessarily shock you, right? If it's a high enough frequency.
Yeah,
So
it's
he's
high
powering
frequency
it with
AC.
some
Don't
cords
believe
at the
that.
bottom.
One I built would put an arc to ground like crazy.
Well, it's a good point.
No,
Yeah.
this one it's a Slayer exciter Tesla coil, and we measured the frequency of Chris Hardiman's replication, and it was megahertz AC. So this actually was
So
it
that
might have
won't
even
shock
been
you.
into gigahertz actually. So it was very very high frequency AC.
Oh, and he comes back out here in a sec. I'll. So yeah, if you're bored, Alexei Chekurkov. The only reason I put this one up is because it was 4K footage, and I wanted to put up something higher res. And when I was done, it came out at 1920, which pissed me off. But he has tons
This
and
is a
tons.
working device. I'm sorry.
The helmet doesn't help his cause either. I mean,
He says he's wearing the helmet because of some sort of radiation he's afraid of, but I don't think he has the theory down, but I definitely believe it's a legitimate, device. We have a replication. Mark went down to Chris Hardiman's lab and flew down there and picked up a supposed American replication of this that we're supposedly going to be getting working in the next few weeks. We have to, get the components out of boxes and hook it up, but apparently it produced 80 grams of thrust.
I think that the helmet is his attempt at showmanship, to be honest.
Wait a minute. Why does it always return to the same spot?
I think
Well, it does have power cords. Just be aware that it has. Yeah, you might not be able to see it well, but it does. He's got 2 or 3 power leads hanging down there.
Yeah, I
can.
Okay.
It has 3 high voltage leads, 2 to each top and bottom rotating plate, and 1 to the center plate.
Yeah, it's kind of like a pendulum upside down. So I guess that's why it's returning to the same spot.
Here, I'll see if I can find a couple more of his.
So it makes me wonder if this guy's like right, but for the wrong reasons. Like he is doing something, maybe there's something that works, and I don't know what he thinks is going on with that helmet and everything.
This is an older one. He put this up.
I actually built this one, but I used different motors than he did, but I didn't get no force out of it.
You got to talk. You got to tell us about.
Did you put a transducer on yours?
I followed his schematics. In fact, he's got a flyback transformer on it too, in the schematics.
Did you put the ultrasonic transducer with the Slayer exciter?
I used the Slayer exciter, Tesla coil. I used the flyback system he had in his. I used some piezoelectrics on there to vibrate it. I didn't see nothing. It'd be nice if I could see the electric. So because, that's one thing you don't really see what he's using. There is some videos where he has a little a box that was a piezoelectric buzzer that he was testing. I assume that's probably what he used in this.
Yeah.
Why is this one at the height that it's at?
I actually, it's an excellent question. I'm not sure if anybody has a good answer for it.
Yeah, the simple answer to that is if it has a constant, amount of force that it can have as a maximum, the more cable it has to lift up, the more mass it has to physically lift up. So
yeah, the cabling would keep it down. That or he's only got a certain amount of fishing line. It depends how pessimistic you are.
Right.
There's one of the videos of a different device that he shows in it that you can see his shadow moving from one place to the other in the video. There's actually a string that's going from the device to a fireplace that you can actually see falling down too. So it's you have to look real close to see it, but it's there. But you see him running back and forth between his control and the device. And I don't believe this at all, but I'm still working on mine, so I'm not finished with all of it. It took me a while to figure out that he was actually using that flyback transformer.
Chris Hardiman has a working replication of it.
Sorry, go ahead.
I was just saying Chris Hardiman was able to get 80 grams of thrust on his replication. So
I looked at the video and it didn't say 80, it said 8.
Okay, I don't know. I'm just going by what Mark told me.
I've been hearing that from these guys too, but I watched the video they told me to go look at, and it didn't say 80, it said 8.
One on Facebook?
Huh?
One on Facebook?
I don't know if it was Facebook or YouTube, but I watched the video that I think Mark told me to go watch, and it said 8 grams, not 80 grams.
Here, let me rewind it.
Which is about a half a pound. And the device I have, I was seeing about a half a pound, but it was always negative regardless of which way I was rotating anything.
So, a pound is like 470 something grams. So.
Well, okay. I was thinking ounces then. But anyway, like I said, the device I got it on a load cell. It doesn't show anything. I think what I'm seeing is a half a pound is just noise into the load cell from the high voltages. It does have some weird effects though, as far as the electrical voltage and stuff on it, that it seems to be putting out a higher current going to ground than the Tesla coil is actually putting into it, which is kind of strange.
What material did you make your rotating plates out of, and what material did you make the center plate out of?
I bought something that looked like his, is leathered aluminum for the rotators. The center coil, I used the same weathered aluminum for the center piece, but I used first one I did, I had a piece of 3/8 wood holding it together because it looks like he's got painted wood on that thing. But then I switched it over to a what do you call that, fiber impregnated whatever that is, the G10.
Now, just in comparison, these are old. These are mine. Those are my lifters. So I mean, I guess one of the problems is, you know, when you're filming this stuff, it all kind of looks fake, right?
Yeah.
Now, in this case, this one, those posts, those are high voltage. It has, and the camera will never pick these up. It has 3 tie down threads, 1 at each corner. So when you would say, why is it at that height? It's maxing out the tie down threads. And
I hope Alex's device actually flies and someone figures out why it does. But I worked on it for about 6 months doing different things, and I've got to go back and redo one of the motors because I found out that the current was actually going through the motor, and I think it burnt the bearings on the motor because it heats up pretty good. But
were your plates rotating in the same direction, or were they counter rotating?
I've tried them in both directions, counter rotating, and nothing really changed.
And did you have magnets on just the bottom plate?
Yeah, I used the one that you saw in his living room. That's the one that I did, and it's actually the one he did, not in that field video, but the other field video he does. It's the same device. And
interesting. Well, I guess we'll find out, because we got Hardiman's device that we have to, you know, see if it flies, and then I don't know if there's something to this. We're going to figure it out one way or the other. Either prove it wrong or prove it right.
You should send me pictures of his device so I can see what's different between his and mine.
Oh, I took 100 pictures. I took 100 pictures of it. Let me give you the Google Drive link. I'll paste it in the chat. I took 100 pictures of it. Let me get that for you.
now in this video here, I don't get close enough to touch it, but the difference is, so with Chekurkovs, I don't know, maybe if it's at megahertz. With this one, if you touch it, you will get shocked really bad. So, and I got bit many, many times.
That's understandable. It's just pretty much an ion wind effect. That's the electric field actually expands way out further than the device itself, so you're entraining a lot more air than you think you are for those devices. I understand those. I've made those too. They do fly.
What kind of voltages did you use?
What kind of wood did I use?
I'm just asking Glenn a question. What kind of voltages did you use on your replication?
Oh, Wait, for me or for?
On Glenn's replication of.
Of Alexi's device.
Yeah. What kind
I
of
think
voltage?
the Tesla coil was probably putting out somewhere between 35 and 50,000 volts. The flyback transformer was actually putting out probably about the same. I was adjusting both of them a little bit.
What about the DC? What about the DC potential between the top and the bottom plate?
Flyback was the DC potential, and it was about the same. I varied it some. I think I could probably vary it between half of the voltage to full voltage on that flyback. I had to make my flybacks.
Do you think it was about 30 kV then?
I based upon the arc length, I wouldn't say it was between probably 30 and 50K, something like that, but that's not a true measurement. I didn't have anything. Well, let's take that back. I did have something. I did put a meter on it. I measured, what was my meter measuring? I don't remember. It was like 6 months ago. I did have a meter on it where I could see what the voltage was. I think I was only going up to about 10K on the flyback, because after that, my circuit would arc. Yeah, that's right. And so I don't know what the other one was doing, because my meter wouldn't read the AC off of the Tesla coil.
Do you have your device? Do you have your device there? Conveniently, are you able to share it, or?
It's actually behind me in this picture. If you can put me up, I can get out of the way.
Hey, Glenn, I just wanted to tell you in the chat, if you go to the chat, I shared the Google Drive link, and I took about 100 photographs of the Chris Hardiman replication. So you can get the photos there.
Anyway, in this, how do you bring my picture up to where people can see it?
Get now. When you talk. Except for when you
Well,
anyway, about the middle of this picture that's in my background is where it's at.
Okay.
It's almost 2 foot in diameter.
Trying to zoom in here. I can't zoom in.
It's that huge thing on the very back end of that table, in the back middle.
You see the
black thing, the black disc.
Yeah, the black. There's like a black circular thing on top of it.
Yeah, you can't. It's like,
what kind of gap? What kind of gap is there between the top and bottom plate, approximately?
I varied that too, probably between a ½ inch up to an inch. It looked to me like his was close to an inch gap.
Yeah. Okay.
All sound good numbers.
How can I share?
You got nothing conclusive. No indication of weight or change.
I put it on a 25-pound load cell, and was looking at the load cell data at the same time I was running it. And like I said, I did see about a ½ pound negative, but it was regardless of which way I rotated anything. So apparently it was just the voltage getting into the load cell. I ended up having to ground the load cell real well to, get all the high voltages out of everything.
Well, as a question, I guess, with Jeremiah's with Jeremiah's model for rotation, right? The two discs, one's rotating and the other one has the force. Maybe there would be some modifications based on that model that could make your thing work better. Sorry, that's a long way of saying something easy, but
For example, magnetics weren't at all considered. The magnetic circuit wasn't at all considered in the design. Aluminum is not an ideal material at all. It's actually a magnetic field reflector. It's not what you want. What you want is a magnetic field grabbing material, which means some kind of fast transient, lamination type of, transformer steel or ferrite or something. Secondly, it needs to have a conductive surface to allow electrons to move around it. So if you have those two things, a magnetic surface that is somehow conductive, then you've got the formulate that you need for closing the magnetic field from each individual magnet upwards. And so what's going to happen is as those magnets are moving, they're going to drag their flux along, and that flux path is going to close in that field, creating, in this case, if the north poles are facing up for all the magnets, it's going to create a south pole on the other plate that's going to have to move around with it. And that's going to drag along any ions that are produced in that area. It's going to create a moving E flux within a moving B flux at 90 degrees, which is exactly what you want for an upwards Lorentz force. And that field has nowhere to go, so it technically would be building over time. Meaning that you should let it run for a while and watch the voltage start to build up to a stupid high amount, and notice that none of your equipment can be near it because it just keeps on building voltage for some reason.
Didn't Chekurkov say that? Wasn't that one of his claims too, that you had to let it run for a while to build up?
Yeah.
I ran it for about an hour.
Oh, wow.
And I didn't see nothing. You couldn't run a radio near it because it would affect it would mess up your radio.
Yeah, the anti-drone technology. Yeah. And no, I noticed that with Tesla coils. Yeah, they knock out all sorts of stuff like that. And then the other thing was when I was building with lifters, the other thing you have to be really careful of, especially with pulse DC, is when you get into those voltages, it'll crawl back up the ground wires, right? So it'll short out computers and stuff. You got to have like a diode on
them. That's crazy. So I agree with Jeremiah. I think that center plate has to be ferromagnetic. We're kind of talking to Charles. He's doing a replication of this too. We're kind of going back and forth on it. But the materials we're using for our replications are tin for the upper and lower plates, and something ferromagnetic like ferrite or iron for the center plate.
Yeah, I was going to use iron on the center plate at some point, but I just built it from what it looked like how he built his. It was aluminum that was bent over around something else.
Yeah, it does look like aluminum on his device. It definitely looks like that.
Do you have magnets on yours, Glenn?
I mean, yeah, that's assuming. I'm sorry.
Yeah, I had the magnets on it like his, plus I put some more on it just to see if anything happened. And like I said, nothing changed.
Okay.
Yeah,
well, that's good to know. Thank you for letting us know, sharing that.
Yeah, thanks for sharing that.
I 3D printed a lot of mine, by the way. In fact, you see that? That's about a 1 foot diameter 3D printed piece. It keeps moving away though.
Interesting.
It doesn't want to stay there, does it? There it is. That's I built the top and bottom out of this device with my 3D printer. This is about a 1 foot diameter 3D print. This is one that I did something wrong on, but I can 3D print a 1 foot diameter piece of plastic.
That looks pretty intricate. I mean,
yeah.
And
I
then
used to do a lot of stuff out of aluminum in my machine shop that now I do it all out of plastics. It saves me a lot of time.
Now, you can 3D print metals too, can't you?
I 3D printed some iron impregnated stuff. In fact, you can see this is actually mostly printed from the PLA with iron in it. A magnet will stick to it.
That's cool.
Do you design those in CAD?
I use AutoCAD and turn them into STL files.
That's interesting.
Very, very cool.
Where did you get that filament?
There's one type. If you'll hold on a second, I'll tell you what type I like the best.
I see you have company, Wayne.
It's just a lifelike doll.
Well, enjoy it while it lasts. Mine is 11. Yeah. She plays Roblox. I don't know if you've heard of Roblox.
Yeah, Roblox.
Yeah, she lives on. Lives on Roblox.
The silk PLAs are the best ones that I've found that print, but the metal one is this protoplasta type, this metal one. It's pretty expensive, about $75 a roll.
Does that work on any 3D printer generally, or?
Yeah, this stuff worked great. I didn't have any problem out of it. They recommend putting this heater on it to take the curl out of it, but it just caused it to stretch. So I didn't use the heater and it worked fine. Just print it like any PLA. You just have to put an iron, the nipple that the filament goes through, it heats up. It has to be iron instead of bronze or brass.
Oh.
So, but I did, it worked fine. I mean, it printed just like any other PLA. No problem about that.
Okay.
But you can buy the aluminum and the copper from them, and they've got videos that shows you how you can make parts and center them, and it actually makes solid parts using
Who's
the
the
filament.
supplier? What's the supplier name?
It's something Foundry. Let me see.
Okay.
Can I make a comment on something that's been buzzing around my head?
Virtual Foundry, sorry.
Virtual Foundry. Okay.
You look them up online. They have a lot of videos for training you.
Okay. I just wanted to mention one more thing. It's kind of a question. I'm just looking for a little bit of input too, if anyone wants to offer. I think Glenn, I believe Glenn has a lot of experience with superconductors too, in the past and all that. So anyway, I got a YBCO superconductor today, and I had it my experiment all set up, and then I realized I was out of liquid nitrogen, so wasn't able to run it. But basically what I'm going to do is just rotate it like I did before and look for any weight changes in a nearby suspended sample. And that's about it. I don't know if anybody has any input there, if they want to.
Yeah, wait, what are you replicating? Because I'm familiar with a lot of things in the literature regarding superconductors and how they might couple to the gravitational field differently than normal matter. And what's your experiment?
Yeah, well, I'm basically just going to physically rotate a superconductor, a YBCO puck, and just see if there's any change in the gravitational field around it or just above it. And this is from my understanding of Dr. Podklenov's reports from the 1990s and how he rotated it.
Have you looked into Martin Tajmar's experiments? Because I know he did some replications and some stuff, and that might help you.
Martin Tajmar is making a career out of debunking everybody, so I don't believe everything he does.
Yeah, actually, if I would say if you wanted to look at probably the #1 expert on the Podklenov experiment in the West, you're looking right at him on the screen right now. So that's Tony. He has more knowledge, more experience. He worked with the NASA replication. He is the guy for superconductors.
I've met Podkletnov, talked to him. I know Martin Tajmar. I worked on the NASA superconductor gravity team. So yeah, I'm probably the #1 expert in the U.S. on what's going on.
So I gotta know, Sorry, I'm getting a little excited at the moment. Do they couple differently to gravity? I'm confused. There are all these experiments on non-classical inertia and using like laser interferometry to try to figure out if there's any sort of like phase shift. What's the verdict?
That's what I want to find out, because there's the literature and there's the stuff. Hard to know what's really true and what really works. So I'm just trying it and seeing what happens.
How are you rotating it? How fast? How are you measuring the what are you using to measure the what kind of field? Like there's like Sorry.
Well,
I have a YouTube video I put up a few weeks ago of an older experiment I did. But in this one that I want to do, I'm going to have the sample just above the superconductor, so very, very close. My older experiment, there's quite a gap, a few inches. So it could be a near field thing too.
Yeah, and Tony could correct me if I'm wrong, but Tony, weren't there, if I remember right, Polkanoff was working with like a 12-inch superconductor, but then there was glazing on the surface. I think you had told me about the glazing, right? It wasn't as simple as pressing on it.
It's melt texture, and he claims it was 2-layer melt texture, where one layer was not superconductive, and the other was. But we never saw the superconductors he had, and we only go by what he said. And his first experiment with the rotating one probably didn't rotate very fast from what we've seen in the design of it, but he was apparently radiating it with microwaves, about 3 megahertz. And from what we think is that he was working on to see if superconductors should be used as a way of cloaking something. That's the reason.
Do you know why? I heard Ningley mention that he irradiated it with radio waves, like in the hundreds of megahertz.
3 megahertz.
You mean 3 megahertz or 3 gigahertz?
No, 3 megahertz.
3 megahertz.
In fact, what was interesting is me and another guy, Dr. Lewis, we measured the cosmic radiation going through a melt textured superconductor. And what was strange is that everything that we had, these scintillation paddles that measures the radiation going through the scintillation paddle to hit in the superconductor, and then measure the radiation coming out of it. All the 6 megahertz cosmic rays that were going into the superconductor converted to 3 megahertz on the other side. So what that tells you, I have no idea, but it kind of tells you that 3 megahertz is something special there, I guess.
Now, do you think frequency has to do with RPM, or do you think there's no relationship with RPM? And
I would imagine the rotation has to do something with creating magnetic vortices in the superconductor. There actually is an effect that if you rotate a superconductor, it will cause these vortices to form in the superconductor.
Now, is that the London moment? Where a suit makes its own magnetic field when you rotate it?
It could be. Like I said, it's been years. I was working on this thing, when I was in my 30s. I'm 66 now, so I can't remember everything we did back then.
So did the magnitude of so you say it went from 6 megahertz to 3 megahertz. Did it change the amplitude on the meters? Did it go up?
When you looked at the spectrum, you could see you see the 3 megahertz spectrum and all the other ones in the 6 megahertz spectrum going in. But then when you looked at the spectrum coming out, the 3 megahertz spectrum was way big, where the 6 megahertz spectrum was a lot lower.
So it amplified the amplitude, but it reduced the frequency. So basically energy was conserved.
Yeah, basically I assume it was conserved.
You know what I'm saying?
Because we wrote a paper on it if you're interested in that paper.
Yeah.
You think it's a type of? I'm thinking it's a type of NMR, like an NMR process there. Hitting it with the 3 megahertz might excite nuclear procession, or do you think? I don't know.
Any radiation going through any materials will scatter. So the 6 megahertz is apparently scattering and coming back out as 3 megahertz.
Is anybody familiar with second harmonic generators? Does that sound familiar to anybody?
Second harmonic what?
It is a term. It is materials. In optics, it's called second harmonic generators, SHGs.
No, I never heard of that.
Yeah, the second harmonic generators are a lot of the materials that I deal with. Some of them, I don't use them much, mainly because it's just not what I made maybe one electret out of a second harmonic generator. There's something called nonlinear optic materials. if you type in nonlinear optic materials and second harmonic generators, a lot of them are the same. They can be different. You can have a second harmonic generator but usually NLOs, nonlinear optic materials, can be second harmonic generators, and some of them are benzene ring based. So it's a good Google thing to do. And since you have these odd numbers, it sounds like second harmonic generation.
It'll be an interesting experiment, Wayne. It'll be interesting to see what you're able to find. Superconductors are just interesting, you know. One of the things.
Is anybody familiar with this book on the frontiers of propulsion science?
Who's the author?
This is edited by Mark Millis and Eric Davis. Is what it says.
Yeah.
It's just a collection of. Yeah.
No, I'm not familiar with the book. Yeah, I know.
Because it has this I can't say the Russian name, but it's covered in here. There's
Pakletnov.
Yeah, I can't say it. It's one of the Russian names I can't say. Easy.
What's the name of the book?
Oh, it's Frontiers of Propulsion Science.
By the way, I was one of the ones they sent to help edit that book, and that title of that book was my recommendation. But everything I did was done blind, so they didn't know who recommended it. But
that's awesome. Yeah, it's just one of my books. I didn't know where to get started, so I spent my Bitcoins on books. I got out too early, unfortunately.
With the Bitcoin, I would say hang on to them. Supposedly they're supposed to go back.
Yeah, no, I got out once they hit, I think it was 1,000 or something. I sold like 10 of them, and that was the last of them. Oops.
Well, we all have a checkered history with Bitcoin. I recall in what was it, late 2017. I said, "Wow, it sure is high. I'm going to put a bunch of money into it."
What we need is to find a fellow nerd that has millions in Bitcoin that would support some of these experiments, because this stuff is expensive. I've looked up how much Visco, YBCO, all these it's expensive, and I don't know. It's hard. Like you can't do this kind of research at like a university easily.
Well, Bitcoin has an energy problem though.
Yeah.
It uses a lot of electricity for the mining operation. So, in order for it to be a currency, I think it needs to find another mode of creating blockchain transactions without the mining.
I think it's also, for me, one of the things that I like about doing this conference is helping to share ideas, information, and educate, right? And so people are doing their own experiments, but for this community, it's good to have a place to come together and share results, even if it's negative results, right? And Jeremiah, as well as Mark, Jason, I don't think you've met Mark Sokol yet, and then Jeremy Reese. There are a bunch of different folks doing experiments. Tony's been doing experiments. I mean, and Ron does experiments. So,
just wait until I start presenting some for you guys. But
yeah, I might have something to present.
Amazing platform for sure. And just to butt in, if any of you guys are looking for more efficient and better cryptos, Algorand is the first carbon negative cryptocurrency. It's the third generation. Also Solana, Cardano.
Bernie, would you spell that? What's it called?
Algorand. ALGORAND. And it goes by Algo, just ALGO on the coins. And it was started by an MIT blockchain professor. It's a really good one. Solana is another decent one that's third generation. It's SOL or SOLANA for the full name. And Cardano, if you haven't heard of Cardano, it's another really good one of the third generation smart contracts coming online right away. And it's CARDANO, and its token is ADA. And all of those cryptos have also just last week been officially endorsed by the World Economic Forum, as well as the Bank of International Settlements and the IMF. So get them while they're down right now. Most of them are just under about $1 a piece, and they're ones that should be going up if you're a hodler.
Yeah. Although, Bernie, let me preface that by saying in our
That is
conference,
not financial advice
that
at
is
all.
not financial advice.
That
Yes.
is just in the
I
market
lost
reality that
everything.
is the simulation that we are all a part of right now.
So yeah, especially and in 2017, I put $4,000 into Bitcoin and Ether. I got it up to 10,000, and then I ended up losing all of it. So not financial advice, but crypto is hot.
So if you're gonna do the markets, this is not advice. Well, this is just advice, but I'm not telling you anything other than look into fractals like the Fibonacci sequence, the Wyckoff accumulation phases, and it shows the fractality of the universe, whether it's even just human emotion, consciousness, or just the mathematics of how cycles play over.
Now, are you talking about a fractal algorithm crypto?
Yeah, no. This is in all stock markets. If you look up the Wyckoff accumulation, it's one just fractal geometry that the charts go in. And the Fibonacci sequence as well plays huge into the dips and the bull runs. It's actually just mind-blowing that they run on these exact same sacred geometric numbers that appear everywhere within our universe, right? So,
I will talk on fractal patterns showing. It was at my school, but I feel like I got this question regarding propulsion. This is driving me crazy for Glenn. If I could squeeze that in.
Yeah, go for it.
Where'd Glenn go? It had to do with the type 1 versus type 2. If there's a difference. I saw the paper you sent, and I just downloaded it using Sci-Hub, and I was taking a look at it, but I began to wonder because a lot of experiments use YBCO and other high temperature superconductors because, well, liquid nitrogen is cheaper, and you can get your hands on these materials a lot easier. It's less expensive than liquid helium and nubium. And so I'm just curious, does this effect has been tested with type 1 superconductors?
I don't know if anybody's done it with type 1. I'd like to do that, but type 1 completely excludes the magnetic field, where type 2 pins the magnetic field, and this pinning may be a key factor in what's going on. In fact, if you read my chapter in the superconducting book that we did, it'll tell you everything. It'll tell you why it can generate a gravitational wave.
Wait, Robertson, I know this name. Wait, there's a paper. Hang on, maybe this was you, maybe it wasn't. It was like something about an enhanced Gertzenstein coupling in type 2 superconductors. Is that you, or I can't even remember who wrote that paper?
Gary Stevenson.
My stuff doesn't get published in journals and stuff. It's like,
that would be probably Gary Stevenson.
I got tired of everybody on writing papers.
Jason, I think that the Gertzenstein effect, Gary Stevenson did a lot of papers on that. Is that who you're thinking of?
No, I just found it. It says R.C. Woods. It says enhanced Gertzenstein effect in type 2 superconductors. But it's not the only paper talking about effects that relate, gravity and superconductors. There's a lot of different theories, and there's a lot of like the same. There's like I've tried to compile once, like all the different theoretical ways to attack this. Matos has a different idea than I have a Dropbox of like 2,000 papers. I'm a bit theoretical with. But yeah, no, there was this. Apparently, type 2 superconductors may, and I think they were saying there might be a way to, I guess, maybe convert electromagnetic into gravitational waves. The coupling is apparently enhanced. That's kind of the key. I just want to throw this thought in there.
The difference between a type 2 and a type 1, the temperature of superconductivity is much lower for a type 1 than it is a type 2.
Much lower, yeah, like a few degrees above absolute zero is type 1. Type 2 was the ceramics that were discovered in like 86 or something.
I believe that Clive Woods or R.C. Woods, if I remember right, he's very ill, and so I'm not, nobody else knows. I believe he's very ill, and so you wouldn't be able to correspond with him now. Baker, like if you, in fact, I can just paste this into chat. Or you know what? Here, I'll just share screen real quick. Sorry. If you did
Baker was in his 80s 20 years ago.
Yeah, no, he's Robert Baker's still alive. Baker is he's probably the high frequency gravity wave person in the world. Yeah, and he's in his 90s now. And then
Wow.
Gary Stephenson knows the Gershonstein effect. That he studied that pretty carefully. And Gary is really familiar with Robert's work. So if you want, I can give you Gary's info.
Yeah.
So, okay.
May contribute to your question, Jason, about the effect that's going on with Podkanov's stuff, with Pulver stuff, and with Black Brain projects. I don't know if you're familiar with Black Brain projects. I'm guessing you probably forget.
No.
So wondering how do these different types of superconductors play a role into producing a gravitational emission?
Say that again. That's something cut out and it sounded like a statement than a question, but then
I was asking if you had a question specifically about how those systems work, or what's going on with the superconductors that can be answered, because I can answer those questions for you about the
well, yeah. I mean, I guess I could ask you how do you? The thing is, I've read many different papers, and they all have a different theoretical foundation that they're standing on. So, but they're all kind of talking about the same thing, that there's some sort of enhanced coupling.
So what if I told you that just in the same way that that the two electrons traveling past the solenoid kind of was a much simplified version, there was an electrodynamic approach to what goes on with superconductors that would allow you to visualize and easily understand what could be going on with Core and Podkanov.
I would yes, please tell me about that. Also, I thought the Cooper pairs model was, well, we'll just go with that. I thought
it depends if you trust a man with giant bananas behind him. Now, if you do, then he can help you out. But
name bananas. At some point,
Are you planning on joining a tattooed monkey live stream sometime soon with all those bananas in the back? I was going to ask.
Just, I think it's the universe's way of ironically telling you that I'm losing my mind.
He's bananas, yeah.
You haven't seen bananas until you've seen Bernie dressed up in a full banana costume dancing on the Shambhala stage on day 4 of the rave, but that's a story for another day. I'm just going to run to the store. I'll be back here in about 20 minutes, but you guys are still live on my channel, and everybody is absolutely loving the discussion. So
yeah. I just put the gravity book on.
I'm going to have to do the same thing as well, run to the store.
Well, I didn't mean to interrupt. I'm sorry. Jeremiah didn't mean to interrupt you.
Oh, Jeremiah. Jeremiah, do not lose your mind. It is great to have you back, brother. Like, you are freaking awesome. Like, I'm going to have to send you some of the samples so you can mess around with all of the red monoatomics to see if it's actually formed mercury oxides, because that would be a proof of some transmutation, because I've never actually used any mercury at all in any of my experiments. But anyways, love you guys. We will see you soon.
I would recommend that if anything, Bernie, you buy yourself a 3-digit resolution scale that can measure at least 0.001 grams. That's 2 zeros and a 1 grams. So if you can get yourself a scale that can measure down to that resolution, and you can get yourself some powder that when you place it on that scale after sitting in darkness for a long time, it weighs one thing, and when you hit it with some amount of light after some period of time, it weighs a different thing, then you would have everybody's attention, and we would all very much be watching and listening to what you have to say. And I would personally love to replicate and test that for you as well if you found something like that. But like I said, I would recommend that.
Not a problem. I would make a joke about my own personal history, but we'll just say I have a couple scales that we can use. And now the only powders that we will be putting on those are that of metal elements.
Listen, I don't care what powders you have on there at the time. Just make sure that you hit them with some amount of light after they've been in darkness for a while to see if they change weight, and then do whatever it was that you were going to do with them.
So I just got 2 10-gram gold pieces that are 99.9. So I'm going to make some pure monoatomic golds to start testing right away, as well as some pure monoatomic silvers. And yeah, we'll record it all, and I'll have it ready for next weekend or 2 weeks from now on the next one for you guys to show some preliminaries.
It's supposed to be, I guess microwave reacted too. So
I've heard that. I've just never wanted to do it around myself, because it's like so many alchemists mysteriously died back in the day, and then you had the Martin Fleischmann who discovered cold fusion and then died of radiation poisoning. So it's like I've heard of all these things, but I need a lab before I'm gonna try putting that stuff in a microwave in my own home, sort of thing.
Well, we would be interested in testing anything that appears to exhibit unique properties.
My last comment of the evening, final comment, a Google of benzene and Cooper pairs. You get a lot of hits. Interesting search.
Well, Ron,
yeah.
Ron, thanks for being with us today. You were here for a long time. Thank you, sir.
Yeah, I'm going to, whatever. Thanks. Good luck, everybody.
Get some rest.
Bye.
Good luck, for sure. We'll need a lot of luck.
Yeah.
Wait, so what's the explanation again? The classical way of looking at things, or the electrodynamic way of looking at things, for why a superconductor, might, because enhanced coupling is kind of the key. The coupling between energy and space-time curvatures is so weak that without some way to, enhance that, you're either going to need astronomical amounts of energy. So you need, or some magical material that doesn't couple the same.
In the book I put in the chat.
What's that?
Yeah, I'm not seeing the link. The chat that I'm looking at right now. Like I saw
I think he put the book. Yeah, he put the actual book in. I think it's the actual book.
Is that the PDF file?
Or download Glenn Robertson.
Yeah. Okay.
It says Glenn Robertson to everyone, and there's a DOI, and it looks like there's a paper.
No, well, yeah, that's the actual book. He put the PDF of the book in.
Or download that right now.
Oh, okay. I downloaded the paper. I didn't have the whole book.
It's Giovanni Modini's, Glenn Robertson, right?
Yeah, see, that's a pretty good giveaway.
Up until so that's 288 pages. That should keep you busy for a while.
Yeah.
I never made any money from it, so y'all can have it for free.
Amazing. I can't wait to check this book out. I highly doubt I've had a chance to browse through this or see this.
I would love. I see the Chow gravity. I've never spoken with Raymond Chow. Actually, I spoke with him briefly once, I think, but I wanted to interview him, and
he was in Estes Park a couple years ago. I met him. We rode from the top of the mountains down to the airport together.
I would love to have Estes. I would love to do some stuff with Estes Park as well. But
you should go next time. They'll probably have it next year at Estes Park since COVID's over.
Yeah, I'll try to go. I'll try to go.
Chow is the guy that talked about the Heisenberg-Coulomb effect, right? How like thin superconducting films could reflect gravitational waves at microwave frequencies. That guy?
Because he's messing with superconductors and gravity wave and stuff now. So
yeah, and then Joachim Hauser, and if I remember right, I'm just looking through the papers here. Joachim Hauser, we were going to have an APEC. His schedule got messed up. You know what? Let me reach back out to him. He was Heim theory. He was the Heim theory guy. And then let me see. Timo. I don't remember who Timo Junker is, but I remember that somebody told me I have to look at his stuff.
There's some good contacts in the book if you can find them. Dr. Lewis, he's pretty old now, so I don't think he'd do anything.
Yeah, and then George Hathaway, and George, I know George is still active, but he's really picky about where he attends or where he presents. And
yeah, George emailed me a while back wanting to know if I had any work for him.
I know he stays busy with a lot of stuff.
He has Hathaway Consulting Services, right? That's his thing.
Yeah, and he's been around for a long time. And then the other one,
I like how all this stuff is familiar. Like this is awesome that you guys like recognize, and I can recognize things that you guys are talking about.
Yeah, well, and then the other one that I saw on an email list the other day, in fact, I'll have to dig for it, was Jacques Vallée, sorry. Right, I see Michael's making a face. Yeah, I did not, yeah, it was in Sarfati's list. And
how about Hal?
Yeah, well, no, Hal's still around. Yeah.
No, why don't you reach out to Hal? He did his
oh, I did.
Oh, yeah.
Yeah, he gave me a very polite decline. He said he's very busy with his new company, and so Eric hasn't responded.
Somebody told me he was here in Huntsville, but I don't know if that's for sure or not.
Well, Hal and Eric both went to the SCU meeting. But that's a one-time event, and it's scheduled a long time in advance, and I think it's more structured in some ways than what we do. So, you know.
There's another Eric. I thought for a second you meant, but Eric Lentz, the new guy. There's a paper published in 2021 that's been getting a lot of attention.
It's the warp drive paper.
Yeah, actually,
yeah.
I reached out to Eric Lentz, and we're trying to. Yeah, I'm just going to write down Jokenhauser here real quick. I reached out to Eric Lentz, and we're trying to get him scheduled. He just has a tight schedule.
Get him on there.
He knows his stuff.
Okay.
There's a presentation on YouTube by Eric Lentz. It's only like a few months old.
Might have seen that.
Yeah, this is I think this is a pretty small community, and it's pretty tight knit. And, you know, that's one of the reasons I'm excited that, you know, we're able to do a conference. I think Estes Park is the same way. We're able to do a conference that helps bring people together. And so far, I think we've avoided personality clashes, except for that one time that Jack crashed the party. But
Jack's a nice guy as long as you don't make him mad.
Yeah.
If you make him mad, you're his enemy.
Yes, there's definitely a walking on eggshells there. So,
yeah. But I talked to him once at the that thing they did in Florida with the 100-year Starship program. I met him down there and talked with him.
Yeah, well, and I'd love to have Jack back on at some point too, but yeah, it is nice to have kind of a tight knit community, and I think it helps to be able to share and coordinate information. Right, that's something that this community hasn't really been able to do well. You know, it's been papers, and I mean, you know, and you've had a few like what was the big one? The big one was STAFE, and then before that it was the 2003 MITRE conference, right? So.
I didn't understand what you're talking about those two about.
I would say those are the big two. Those are probably the big two events where people kind of come together and share. Other than that, it's just been email. So, yeah. So to be
I did the conference for 3 years there, and Maria did STAFE too, but I never went to any of those. And yeah, there's not much going on as far as I'm concerned. They've got that Starship Congress I went to a couple of times. But that 100-year Starship conference is a bunch of the girl who's in charge of it. Basically, what I was told, it's all about her. And I never went, but
so hey, I got a question for you guys. I've been thinking about this 9-page thing that they put out. One of my hobbies is pestering the government, and I thought that this could have was an opportunity to do a bunch of FOIA requests, Freedom of Information Act. And my experience doing FOIA requests is it's hard to get them to cough something up unless you get some key word or key phrase or something you can reference, okay? And this gives me something I can reference now. So they have 144 and only one of them they identify, right? So, well, then they should be able to release those other 143. So basically, I know they exist. The 143, I now know they exist. And so I want to see them. Okay. So unless they're classified, they have a responsibility under the Freedom of Information Act to disclose them. Now, they could probably claim some protection somehow, but if they're not protected, they can't claim it. And then if they don't give them to me, I can go to court, federal court, and the federal court will say, give them.
Well, I think, yeah, you could probably request them as UAP, you know. Why not reference that? You could reference the report and say, I would like more information pertaining to, I would like to see examples of these reports that were referenced in this document. I know there are 144 of those, you know, and then I think they probably, if FOIA, wouldn't they have to provide them, but then they could just black out a bunch of it?
Well, yeah, they could black it out, but they would have to claim an exemption from FOIA somehow. Say, yeah, we're blacking it out according to this exemption under the Freedom of Information Act. Like, for example, if it had the name of the general that was on the document, they black that all out. You know what I mean? So what personal stuff, they always black out.
Yeah.
Right. Some of it, but if they've disclosed something, so for example, they said they had infrared data, they had radar data, they had EMF, they had RF data, they had all kinds of data that they were talking about.
I would like to see that. I would like to know more about the RF data. Supposedly they picked up what you know, they said there was RF emanations, right? So
right,
that's very vague. It doesn't sound like it was a broadcast. It sounds like.
Well, I'm curious if when they say RF, they were their systems were affected by RF. You know that EMF pulse image I got where the Tic Tac sending this obviously some kind of pulse and it's heading right towards the aircraft, and then the fan out on the IR detector lights up. Okay, so you can see it at the back, like backlights the infrared detector, and I can see the pattern there. That's because something caused it to get a pulse in it. Okay, electrical pulse. So is that what they're talking about? I don't know. But they bring it up. They've given us the wording that we need to use to get them to release information, okay, is the way I'm looking at it.
Yeah.
The other thing is that I thought was kind of interesting, it said the word preliminary on it.
Yeah, and I think it might have been preliminary as related to the ongoing work of the task force, right? So that was kind of my take on it was, here's a preliminary report on our work, but if you're a civilian, you might never see the rest of it, you know?
So now the other thing that was missing that I was looking for was stuff about USOs, unidentified submerged objects. I didn't really see much about that.
No, yeah, they didn't.
I didn't see anything about that.
I don't think it was pertaining to the report. I think that was, right? The report was, so when Congress passed it, it was relating, because if you read the report, they're like, here's what Congress said we had to provide. Here's what we're going to provide. You know, but I think
that's another avenue for FOIA requests, because just because they didn't ask for it doesn't mean I can't ask for it.
I think it was, maybe it was Frank. Somebody else had said that that it took 3 years for the September 11th report, or something like that. It took a couple of years for the 2008 crash report. I don't know if you ever read that, but that was actually, it was very well written, and they didn't pull any punches. The 2008 crash report was really good. That was 400 something pages. So with this, the person who told me this said they did not have enough time to do a good job. That they basically, Congress should push for something real, you know, like a September 11th style report.
But maybe they already have the report, they just haven't released it because it's in a draft form.
Could be.
So possibly we can get that information under the FOIA, because I don't think there's any protection under FOIA for draft stuff.
I mean, to me, it seems surreal. Maybe, I don't know. Maybe I'm just a Okie from the sticks, but you know, it does seem odd for the government to be saying UFOs are real. That wasn't on my list of things I expected to hear this century. Bitcoin, I'm okay with Bitcoin, right? That's crazy, but it's kind of our type of crazy. But you know, we're being visited by aliens.
Chaos theory, right, is okay with you, but
the
fluctuated equilibrium, that's a different story.
Well, I don't know. I mean, now I guess if you're a big black project believer, then it could be ours. But I'd say I'm not. So that leaves aliens or time travelers, and then the other one is maybe it's an ancient race that evolved under the sea. So basically, it's like the man from Atlantis. Those are your choices. I'm not.
Those are all cool explanations. I like them all.
Aquaman. That would be, yeah. I'm not buying Aquaman.
Well, what if it's like more like what was that movie? You know, it's like an evil genius.
Well, that would be NGOs, right?
The NGO, yeah, the non-governmental, or it's like Elon Musk's evil twin.
Did you see that? But did you see the Jeff Bezos petition? I don't. This one I have to share. This is more in the humor category.
Oh, geez.
Yeah.
Humor is always welcome.
Okay. Well, no, this one is. And you know, sometimes you get something in like your social media and you're kind of tired. So I was scrolling through. Where's my Zoom?
I'm really into memes.
There. So I was scrolling through my social media feed and someone forwarded me this.
Oh yeah. I've seen that one. Do not allow Jeff Bezos to return.
So when you said UAPs could be an evil genius, I thought, well, no, because we know what the evil genius is building, right? So we already know he's got a rocket. So then that rules out the evil genius right there. It has to be something else.
Well, no, that could be third generation stuff, and he's on the fifth.
Third generation evil genius.
He can only release that because, you know, then the reptilian overlords would be upset.
Oh, I see. Yeah, there you go. Yeah.
Because, you know, he is not really a billionaire. He's like Trump.
And, well, I mean, no, being serious.
Only on paper, to the bank.
Everything I've seen is rockets, including hypersonics, right? I mean, you're dumping fuel out the back. It's an open air rocket, but, you know, you're still burning kerosene.
Yeah, no, nothing is... well, we have seen something. The question is it ours? Or is it somebody else's? Or some other entities besides humans, right? It doesn't have to be aliens, you know. It could be highly developed porpoises, or cats, even better yet.
Well, wait a minute. They say they've been
assume that intelligent life is limited to humans, right?
Yeah, they say they've been hiding among us. That would explain cats, you know.
Well, we work for them from their perspective,
and they're not particularly trustworthy, I would say, you know. So yeah, I can see cats.
There's something with a small brain like a cat. That means their brain is partially in another dimension, so it's bigger than what it is.
Well, if you understand transdimensionals, okay, basically humans, all life is transdimensional, okay? And that's why you can have like ghosts of like your cat or your dog.
Well, yeah, no, I mean,
because that's a form of transdimensional. A ghost is a transdimensional person.
You're jumping subjects a little bit, right? But it is interesting.
A little.
Well, yeah, no, you're getting into the Penrose Hameroff stuff, but that was interesting because Stuart Hameroff has. he has an interesting case that the brain might be quantum, right? We might do quantum processing in our brains.
Right.
Which would explain why AI is nowhere, because supposedly the computing power of machines was supposed to overtake the human brain. And what he was saying was, no, every microtubule in the brain is a quantum processor. So it will be hundreds of years, even with Moore's law, before that happens.
Oh yeah, there's no way that it's kind of like comparing digital to analog.
But if that's the case, if it's quantum, then you really could have transdimensionality in
oh yeah,
the mind.
No, it is. It is, because basically, is an imaginary real? Is what we're talking about. It's in the imaginary's context, it's real, right? In that dimension. So it's kind of like it's kind of hard to wrap your mind around, because it's kind of like probabilistic but deterministic at the same time.
Yeah, it's probably, I mean, maybe, I don't know. I've thought that stuff like that maybe is like 25th century or 30th century physics. You know what I mean? Like, I don't know. Kind of what the government is saying about UAPs. It's stuff that's, science that's still waiting to be discovered, I guess. Maybe that's the way to look at it.
Well, I think we're just we're at a wonderful inflection point, is what I think's going on. It's like we went from a world where information was super highly regulated and controlled to one where it's everywhere. We have so much information at our fingertips like we never had before. And it's an opportunity, but it certainly could be a bottleneck too for our species.
No, that's a really, really good point, Mike. And I've seen it evolve so much over, like, especially just since January, since 2021, now that there's been like the year of like the lockdown and like society shifting, changing, getting in touch with themselves, going within, and then this mass awakening. And that everybody is now, it was the jump start into the actual 21st future, where now we're all doing these weekly, everyone's connected face to face. We actually have these telephone, TV, connections that it was always around, but it wasn't being utilized.
Well, first we had to have an implosion.
Yeah, right, exactly. The opposite end of it.
It all had to collapse.
And that right there couldn't be a better, oh my goodness. Just example though of the alchemy cold fusion electrolysis that I'm working with myself. And if you guys don't mind, I'll bring up on my YouTube channel just some of the pictures and stuff of the self-organization that happens as it spirals inwards, as well as like the nano structures that form and build. And it's like there's like dragon spires of this like plasma as it's alive with the electricity going in, coming off of the anode. And then you have like these nanotubes form within like hours that go through the entire jars and process. And there's like a 3-day cycle where everything will turn from an oxide on the anode into what Keshi claims is deuterium, but it's like a complete black layer. And then it stops eroding and it turns into like essentially like a 2D or almost what is the zeros and ones, binary life kind of pattern or intelligence or design and structure of how it builds and is essentially alive and forms itself through these self-organization patterns.
So would you say it's like a budding process?
That is a good way. Yeah, that is actually a very good way of putting it, for sure.
So, because that's a self-replication, self-organizing which is kind of what a fractal is. A fractal is a type of
So
process. So
I've been creating a
so
like
interesting point on
higher
that.
dimensional
There's this kind of
geometric.
life called a hydra. You ever heard of a hydra?
Like the Hydra Dragon of Seven, or
Oh yeah, you know, in the
cut the head off and it comes back.
in the myth, in the Greek myth, it's this lady that has snakes on her head, right? But the Hydra is actually this critter. It's a little. It looks like like an octopus or a squid attached to a rock. Okay,